Hello and welcome to I Create My Games. I'm Jens and this is Path Movement 101, working with the predefined path. Let's first take a quick look at the prepared demo scene. Now for everyone familiar with my previous video, Walk the Line, you will see a lot of similarities because I'm using the exact same asset set and my character still has the exact same script attached. So if I click somewhere, I will walk in this direction and it's validating inside this script. Now for this tutorial, we want to do this a little bit different. We have a path set up with a script attached, which doesn't have any logic yet. And inside this path, we have a few points we want to travel to in this specific order. So we want to verify which ones are inside, and inside our path creator even validate if the path is possible or not. So we will change the path follow a little bit as well. And with that, let's jump right in. Now inside our script, we first need a way to reference our transforms. So let's create a list for that because we don't know how many we will actually need. Then let's also create a method to set everything up. This is a first draft, we will extend it later. So here we verify if we already have the list set up. If not, we create a new list. Otherwise, we will clear everything already existing in this list. Then to get our transform children, we can use a simple for each loop with our current transform in the in part. So we add simply every child of our current transform to our list. Now to display everything, I like to use the onDrawGizmo method because this is a good way to show me inside my scene view or design view what is actually going on. And here I need to set up the path and loop every single point, or better point tuple, to create a line between these two positions. So if we go back to Unity, we can already see the gizmo line drawn. So if I display the gizmos or not, we can see the path we want to travel. Awesome. Now let's make sure that we can actually travel these points. And to do that, let's store this information in a Boolean array. And for that, the size is always the same as the amount of points we have, -1, because we always have one less connection. Now to verify that, let's create a short method, check possible path. This will receive 2 points, the first one and the second one. So we can simply call it the same way we do with the drawLine method. Now, the actual checking will be the same as we did last time. So we just copy the code. It's basically get the direction from the 2 points, store it in a vector2D, of course. And then we need to raycast from point 1 in that direction with that length and verify for each and every one of these if we have collided with the wall or not. If that's the case, well, then we can travel this path. Now for the assignment, we can use basically the same logic as for the drawLine. We always need a point and a successor, so we can simply assign the value with the method. Now, since we are currently only drawing white lines, let's create another method to decide if we want to draw a red or a green line, depending on if it's actually possible to move that path or not. So we need point 1, point 2, and if it's possible. Well, if it's possible, then I want the gizmos to be the color green. If it's not possible, then I want the color red to be used. And well, the drawing of the line is the same as we did before. So we can simply copy this and change it to point 1 and point 2. And for the method call, we can simply change it up there and give it the isPathPathable from our previously array. If we switch back, we can see that everything works as expected. We have the green lines, and if I start moving a point around and I start crossing a specific collider, it just simply starts appearing red, so it's not possible anymore. Now keep in mind our current validation method is a bit slow since we're using the Raycast all method, so let's go over a quick fix to make it more performance optimized. And to do that, we need a Layermask, and let's call it walls. We could also use multiple layer masks, but for us one is enough, and assign it to the one with the colliders we want to check. Now, since my zombie doesn't have the walls collider, we won't check this anymore, but we need to change a few things in the script. So in the script, we need a way to store this information, and this is possible with an integer, Layermask to check, and we can assign this value in the setUpPath method with the Unity provided Layermask getMask method. Now, if we want to use multiple, we can just simply add multiple strings here. Then we change Raycast all to Raycast and add the Layermask inside this Raycast method. Then we change it to only the single hit we get back needs to be verified, and we don't need to verify the string itself, and we're done. And if we switch back to Unity, we can see that we do exactly the same as before. The logic or the functionality is the same, but now it's a bit more performance optimized, which you can't actually see, but you can trust me on this. Now let's make sure that we can actually use it in our game. So first we need to make sure that we call the setup method at some time. We will use awake for this. So it's set up once in the beginning. Now, if it's set up only once, we don't see any changes. So let's also create a coroutine to verify if we changed something. If that's the case, then we want to, well, redo the setup. So here we wait, in this case, for 0.1 seconds, but for you this could be totally different every time you implement it, so you might use it as a parameter. Now, to actually verify if something is changed is a little bit more tricky. We will get to that. First of all, if we don't have any points, so it's null, then of course it's not up to date. That's easy. The second one is also pretty easy. If the child count is different than the ones we have in our points, so a new point was added, then it's also not up to date. The last one is a bit more tricky because here we verify a flag, a dirty flag that we can only ourselves set to false. So if the transform item has changed, is true, then we want to verify or say that we're not up to date, but we first need to set it to false ourselves. Unity would set it to true, but we need to set it to false so it doesn't fire always. Otherwise, the path is of course up to date. Now, in our coroutine, we verify that. If it's not the case, then we want to reset up everything. And we of course need to start the coroutine in the awake function. Start would work as well, by the way. Now, the same logic can be applied to the draw gizmo because we don't need to calculate it every single time, and we're good to go. Now, if we switch back to Unity, we can see that it's working pretty much the same as before, but now it's usable when we're playing. So the next step is to set our little zombie on its path. Now, keep in mind that the gizmos we're using are reacting instantly, so if I change something, we can see these changes without any problem, without any delay. Now, for our actual path, this wouldn't react that fast, but 0.1 is usually fast enough, but it's still way better performance-wise than checking it every single frame. If you have a static path, you can even skip this part completely. Now, to set him on his path, we need two more methods in the path creator. First of all, let's verify if the requested point is actually possible. Because if our path points aren't initialized yet, or the amount of points we have is actually 0, then we can't do anything. Now, if the requested index is smaller than 0 or bigger or equal to the amount we have in our array, then again, we can't do anything because we're outside the bounds. Now, if the index is 0, then we're good to go because it's the start point and the other checks are already dealt with. Otherwise, we can simply call on our Boolean array, which holds the information if the path is possible for this connection. So we need the index -1. So the connection from 1 to 2 is stored in index 1. Now for the point itself, we verify if the point is possible. If that's not the case, then we can simply return a vector3 0. But if it's the case and we can use it, then we can simply grab the index of the path points, which is a transform, and then grab the position, and we're good to go. Now in the path follow 2D, we can delete a few things. The box collider and the camera isn't needed anymore. Then the update method, we don't need it as well. For the setup new target, we can simply change it to accept a new position. And we don't need to grab the position from the mouse. Then we don't need to verify the colliders because we do this in the path creator. And in our follow path, the distance check is changed with out the collider. Now, to set everything up, we first need a reference to our path creator and, of course, an index for the current point we're at. In the start method, we set our transform to the very first, so the start position. And then we can set our current index and set everything up for the next path. So we make sure that we can use the setup new target method with the current index. So it's path, get point, current index, and we're good to go. Now, further down, for the follow path, once we reach one specific point, one checkpoint, then we can simply increase our index and verify if we can, well, go to the next point or not. So is point possible for our current index? If that's the case, then we can simply set up the next point. Otherwise, we do the same as we did before, we just stop. And we're done. So if we now switch back to Unity one last time, we can now grab the reference for the path and hit pause and play, so we can see that our character is repositioned to the start in the start method. And then when we uncheck pause, our character is moving from position to position. The cool thing is, now since it's in the start and everything, we can duplicate our zombie and it's doing the same thing. So for a tower defense game, we're all set up. And with that, we're done for today. In the next video, we will expand the used scripts. For example, a feature to loop back around to the start and a notification about changes of the path are crucial for anything a bit more dynamic. If you still got time, maybe check out one of my other videos until then. If you haven't subscribed yet, now is a great time to do so, and it also helps me and my channel really out. Thank you guys so much for watching, and I see you next time.